So let's see if we can handle this last problem. So based on concepts of atomic structure and periodicity, propose a modification to the student's previous hypothesis to account for the compounds that form between halogens and fluorine. So what is his hypothesis? His hypothesis was clearly that there was only one, and it was a ClF, and that was it. But there's clearly more than that, though, because we can include the ClF3. But if we can include ClF3, can we include then a ClF5, okay, like you see down here for bromine? Okay, so let's talk about that. First of all, let's discuss the fact that there's always going to be an odd number of fluorines attached to a halogen, simply because for all of these, you have one single electron on one side for all of them, which means there's going to be at least one, and then you break them up in pairs, which means you have, so it's like counting, like you have 1 or 3 or 5 or 7. The reason why you can't have, and chlorine doesn't do that, and I'll explain why in a second. The reason why you can't have, though, an even number is that if I get one here, like this, and I go for 2, that means I still have a single electron there. And you can't have a single electron. That structure is typically, sometimes it happens, but typically it is not stable to have a single electron. So you're not going to see an even number of fluorines, so that you get rid of, like you use the electrons evenly. That doesn't make sense. You use electrons so that there's no single electrons being left on the central atom. So that's why it's either 1, 3, 5, or 7. Now we see 1, 3, 5, or 7 for iodine. I'm going to show you the difference between chlorine. Well, first of all, I'm going to show you the difference between these two are going to act similarly, and I'll show you why. And then this one is going to kind of be standalone, and I'll show you why that is also. Okay, so first let's take a look. It says, based on concepts of atomic structure. Atomic structure in this case means that we're talking about atomic structure is not the number of protons, the number of neutrons. We're talking about the number of electrons. The number of electrons for chlorine is 17. Okay, 17 is the atomic number. It's the number of protons, but it's also the number of electrons. So 1s2, 2s2, 2p6, 3s2, 3p6, and I got down to, it's not 3p6, it's 3p5, because I don't want to overshoot. So I count this number here. I got 2, 4, 10. Right here I'm at 10 electrons. And then I have 2 more, which is 12 electrons, and then another 5 is 17 electrons. Okay, so here I have a situation where I have 17 electrons. What comes after that? Well, the 4s2 does, and then the 3d. Okay, so the 3d is completely open, the 4s is completely open, but the 4s is just a little bit higher than the 3d is. This is where these extra bonds are coming from. So when I break this up, this is the part that's confusing. When I break up that lone pair into fluorine here, I can break it up into, well, first of all, I can have just one fluorine like this, and that's standard. There's nothing hinky going on there, nothing unusual. But then when I get to 3 fluorines, that means now that my chlorine has gone past its octet. What do I mean by that? Octet is 8 electrons that the chlorine likes to have. Now I'm at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm at 10 electrons that are outside the chlorine, okay, because it counts all of those as part of its now electronic structure. Okay, so 10 electrons is more than, and so where do those 10 electrons go? They go to the D that is not filled. And it's the reason why it can is because it's all part of the same major energy level. This is something we covered back in chapter 8, I believe, of last year for the honors chem. So because we can go past for for any element that's in period 3 or lower, or higher, I should say, period 3, or here's what I'm talking about. Take a look at the periodic table. Here's period 1, going all the way across, hydrogen and helium. Period 2, lithium to neon. Period 3 goes sodium to argon. Period 4, period 5, period 6. Okay, now after, so once you get through period 5, notice what happens down here in period 6. What is this block? This block right here is the bottom portion. Period 6 and period 7 have right after the S block, right after the cesium and the barium, now goes to the F block that is down below. Okay, the F block here, let me scroll down just a little bit to show you. There, right there. So this is 4F, this is periods 6 and 7, and that represents 4F and 5F. Okay, so once we get down to the F's now, just like if I have iodine, and here's the, okay, I'll get to that. I need to go back again. So I'm going to go back, I'm going to go back to here. I'm going to scroll down. The electron configuration is the reason why. So, so right here, CF, I have one here, and one here, and then I have that and that. This is okay. I got 10 total electrons, but that's fine because I have a place for those to go. Now look what happens if I do this one more time. Can chlorine get a total of 5 fluorines? That means I have a lone pair there, and I have 5 bonds. That gives it, that's an octahedral. Octahedral, when I go back to here, I scroll all the way down to the bottom. Octahedral is 6. If I have all 6, like you will see sometimes SF6 like this, which means fluorine, 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 and fluorine. So that's octahedral, okay, when you split up all of sulfur's lone pairs. So look what happens if I have 6, but one of them is a lone pair, then it starts to look like this, where one of the lone pair is like that. There's the lone pair. Doesn't that look a lot like my chlorine? Doesn't that look a lot like my chlorine here, where I have 5 bonds and one of them is a lone pair? So this can happen for chlorine, and it does happen. So ClF5 is a valid structure. So there is another thing I can add. There's something else I can add to modify a thing. Yes, this does happen. That is a yes. ClF5 does happen. It's a stable structure. So it does happen for BrF5 also. So what's the difference between bromine and iodine? The IF7, where's that coming from? Well, let's take a look very quickly at I. Iodine is, where am I at here? 53 electrons. I'm not going to go through all of it. I'm going to use my noble gases. The noble gas for iodine I would use is krypton. Krypton ends at, what would that be? 1, 2, 3, 4p6. So everything after that would work. So that would be 5s2 works. So after 5s2, yep, I'm good. 5s2, where are we at here? That would be 5s2 goes to 4d10. So first of all, krypton is 36 electrons. So there's 38 electrons. I'm going to get rid of this just so I can continue on. This would be 48 electrons. After 4d10 goes 5p6, except it's 556. 5p6 would be 54 electrons, and that's xenon, so that's not it. It's one less, so it's 5p5, like that. And that's how I get 53 electrons. So that means that what I have then is a 5D that's open with none, because that would come after. And I even have a 5F that is open that comes after. And because I have both 5D and 5F, that's where the places for the IF7 comes from. Notice that chlorine and bromine do not have the extra D or F, I don't believe. So that's how I would explain it. Looks good to me, and, you know, great.